I'm focusing on the TweedieRegressor model, specifically its power parameter, p. This parameter is crucial because it determines the type of Tweedie distribution we're using. We'll be tackling a multiple-choice question about the Tweedie distribution and its properties. The question tests your knowledge of how the power parameter p affects the TweedieRegressor's behavior. I'll evaluate each statement's accuracy. If the power parameter p equals 1, we have a Poisson distribution. This is relevant for count data, where we model the number of events that occur within a certain interval. When p is between 1 and 2, the model accounts for situations with more zero values than a standard Poisson distribution would expect. This is often useful for insurance claims, where many people have zero claims. Setting the power parameter p to 0 doesn't give us a Gaussian distribution in this context. Instead, you'd use a Gaussian regressor for that. That statement is incorrect. Increasing p actually decreases the model's sensitivity to outliers because it makes the model less sensitive to extreme values. I'm ready to select the correct answer choices from A, B, C, and D based on my analysis of each statement. Hey Vamsi, let's dive into the TweedieRegressor. It's a powerful tool in Sklearn, a popular Python library for machine learning, used for regression tasks. The p parameter is what makes it special, controlling which specific type of Tweedie distribution it uses. It's like having a toolbox of different distributions all in one. If you set p to 1, the TweedieRegressor uses the Poisson distribution. This distribution is perfect for modeling count data, like the number of insurance claims. Think of it as a specialized tool for counting events. This is where things get interesting. When p is between 1 and 2, you're using what is called a compound Poisson gamma distribution. This distribution is especially great for dealing with data that has a lot of zeros, like insurance claims, where many people don't file a claim. It is designed to capture those extra zeros. Actually, that's incorrect. Increasing p has the opposite effect. It reduces the model's sensitivity to outliers. Imagine it's like smoothing out those extreme values. It makes your model more robust, preventing extreme values from overpowering the rest of your data. This is a multiple-choice question testing your knowledge about TweedieRegressor and its amazing ability to handle various data types. The questions will help you verify your understanding of the Tweedie distribution's flexibility and its relationship to other distributions like the Gaussian and Poisson. While a p-value of 0 relates to a Gaussian distribution, we wouldn't use TweedieRegressor for that. We use a Gaussian regressor instead for Gaussian distributions. Think of it this way. Each type of distribution has a best-suited tool. I'm focusing on the TweedieRegressor, a powerful tool in Sklearn that uses the Tweedie distribution to model data. A key part of this distribution is the power parameter, p*, which dictates the specific type of Tweedie distribution used. Different p-values correspond to different distributions, affecting how the model handles your data. Think of it like choosing the right tool for the job. Different distributions are better suited for different types of data. If you set p to 1, the TweedieRegressor becomes equivalent to a Poisson regression model. This is perfect for situations where you're modeling count data that represents the number of times something happens. Think of the number of insurance claims, for example, where a claim can only be a whole number. It's important to note that the Poisson distribution assumes the data is non-negative. When p falls between 1 and 2, the TweedieRegressor uses what's called a compound Poisson gamma distribution. This is useful when you're dealing with data that has a lot more zeros than you'd expect from a typical Poisson distribution. This is common in insurance claims data because many people will have 0 claims in a given period. This special type of distribution is really good at handling those extra zeros. This is a multiple-choice question designed to test your understanding of the TweedieRegressor in Sklearn and the implications of using different values for the power parameter, p*, in this model. Each choice presents a statement relating the parameter p and the resulting distribution behavior. The scenario is straightforward. You are using "TweedieRegressor" from Sklearn to build a model that predicts insurance claim amounts. These values are non-negative and have many zero values. This is where understanding the power parameter p of the Tweedie distribution becomes crucial for properly modeling your data. If p equals 0, the Tweedie distribution behaves like a Gaussian or normal distribution. However, this would not be a good choice for modeling data with many zeros, like insurance claims. You'd likely want to use a different regression model such as Gaussian regressor for this scenario. The opposite is actually true. Increasing the power parameter generally decreases the model's sensitivity to outliers because it shrinks the heavy tail of the distribution. I'm exploring the TweedieRegressor, a powerful tool in Sklearn for modeling data with many zeros, like insurance claims. It uses the Tweedie distribution, a flexible family of distributions controlled by a power parameter, p. Understanding how p affects the distribution is key. This statement is false. A p-value of 0 represents a Gaussian distribution, but I wouldn't use TweedieRegressor for that. I'd use Gaussianregressor instead. This is true. When p equals 1, the Tweedie distribution becomes a Poisson distribution, perfect for modeling count data. Absolutely correct. A p-value between 1 and 2 gives me a compound Poisson gamma distribution. This distribution is excellent for datasets with many more zeros than a regular Poisson distribution would predict. Think of insurance claims. Lots of people have 0 claims. Nope, that's incorrect. Increasing p actually makes the model less sensitive to outliers. The heavier tail of the distribution gets shrunk. The correct answers are B and C. Statements B and C correctly describe the Tweedie distribution's behavior and its use in modeling data with excess zeros. I'm looking at the TweedieRegressor, a powerful tool in Sklearn that handles non-negative data, especially data with lots of zeros, like insurance claims. The core of this tool is the power parameter, p. It dictates the type of Tweedie distribution used. Different values of p correspond to different distributions, like Poisson or Gaussian. We'll explore how changing p affects our model. If you set the power parameter p to 1, the TweedieRegressor uses a Poisson distribution. This is perfect for data that represents counts, like the number of claims. Pretty cool, huh? When p is between 1 and 2, we're using a compound Poisson gamma distribution. Think of it like this. A regular Poisson distribution struggles when you have a ton of zeros. This version adds a layer to handle those extra zeros, making it suitable for situations like insurance where many people have 0 claims. It's like adding a special ingredient to our model. That's incorrect. Actually, increasing p makes the model less sensitive to outliers. The heavier tails of the distribution get less heavy, reducing the influence of extreme values. This question tests your knowledge of how the TweedieRegressor works, focusing on how the power parameter, p, changes the model's behavior and which distribution it uses. Remember, we're focusing on the mathematical properties. That's wrong. A power parameter of 0 corresponds to a Gaussian distribution, but we wouldn't use a TweedieRegressor for that. We'd use something like a Gaussian regressor instead. I'm going to explain the TweedieRegressor, a tool we use in machine learning to model data that's similar to what you might find in insurance claims. Think of it like a super flexible tool to model non-negative numbers that frequently have 0 values. The p is called the power parameter, and it's the key that unlocks different types of distributions that the TweedieRegressor can use. I'll explain how various values of p relate to different well-known distributions. If you set p to 1, the TweedieRegressor uses a Poisson distribution. Think of this as a good model for counting things, like how many insurance claims a person might file in a year. This model is specially designed for cases where the number of events, like claims, is low. A Poisson distribution works well if you assume each claim event is independent and happens at a constant rate. When p is between 1 and 2, the TweedieRegressor uses a compound Poisson gamma distribution. This is really useful when you have a lot of zeros, many people not making a claim, in your data, more than what a basic Poisson model would normally predict. It's like adding extra oomph to account for those excess zeros. It cleverly handles those situations. Actually, the opposite is true. Increasing p makes the model less sensitive to outliers. Outliers are those extreme values that can pull your model's predictions away from the majority of the data. A higher p means that the model is less influenced by those few extreme values. We're using TweedieRegressor from Sklearn, a powerful tool for modeling data with a lot of zeros, like insurance claims where many people have zero claims. The key is p, the power parameter. It controls the type of Tweedie distribution we use. Different p values give us different distributions. This is a multiple-choice question testing my knowledge of Tweedie distributions and how the parameter p affects them. I'll analyze each choice carefully to see which statements are true. If I set p to 1, I'm essentially using a Poisson distribution. This distribution is perfect for modeling count data, like the number of claims, where you can have 0, 1, 2, or more. When p is between 1 and 2, I'm using a compound Poisson gamma distribution. This is great for data with more zeros than a regular Poisson distribution would expect, which is very common in insurance claims because many people have no claims. I've learned that this is actually false. Increasing p makes the model less sensitive to outliers, it shrinks the heavy tail. This question focuses on understanding how the TweedieRegressor works and how the p parameter changes its behavior. If p equals 0, I am using a Gaussian distribution. But we usually use Gaussian regressor for that instead of the TweedieRegressor.